Here's the structure that holds it together, the triangular fibrocartilage. It's also known as the articular disc. It's attached to the radius here and to the ulnar styloid here. As the distal end of the radius rides around the head of the ulnar styloid provides the pivot point. Now let's look at the wrist joint. Though we often speak of it as one joint, there are really two joints here, very close together. They're called the radiocarpal joint and the midcarpal joint. To understand them, let's look at the bones. We'll look at them this way up. 8 small carpal bones form the carpus. Distal to the carpus are the metacarpal bones, numbered 1, 2, 3, 4, and 5. The carpal bones are in 2 rows, a proximal and a distal. The bones in each row are attached closely to one another. The 4 bones of the proximal row are the scaphoid, the lunate, the triquetral, and the pisiform, which sits by itself on the triquetral. The scaphoid, the lunate, and part of the triquetral articulate with the distal end of the radius to form the radiocarpal joint. The distal surface of the proximal row forms a deeply concave notch which the bones of the distal row fit into. The bones of the distal row are the trapezium, the trapezoid, the capitate, and the hamate. The capitate and part of the hamate project proximally. The bases of the 5 metacarpals articulate with the distal row of carpal bones. The first, the one for the thumb, articulates by itself with the trapezium. The other 4 articulates in a row here. The distal row of carpal bones articulates with the proximal row here to form the midcarpal joint. The projecting capitate and hamate fit into the notch in the proximal row. When flexion and extension occur at the wrist, the movement happens partly at the radiocarpal joint and partly at the midcarpal joint. When radial deviation and ulnar deviation occur, the action happens mainly at the radiocarpal joint. Here's the wrist joint, or rather joints, with much of the capsule removed and the 2 collateral ligaments here and here intact. Here's the radiocarpal joint. Here's the midcarpal joint. The radial collateral ligament goes from the radial styloid to the scaphoid and its neighbor, the trapezium. The ulnar collateral ligament goes from the ulnar styloid to the triquetral and pisiform bones. Here's the wrist joint with the joint capsule intact. The joint capsule is thick and strong all the way round the joint. On the extensor aspect, the capsule forms the broad dorsal radiocarpal ligament. On the flexor aspect, it forms the palmar radiocarpal ligament. Unlike the elbow, which is held together partly by the interlocking shape of the bones, the wrist joint is held together entirely by the strength of its ligaments. The 2 collateral ligaments hold the bones together in radial abduction and ulnar abduction, and the radiocarpal ligaments hold them together in flexion and extension. The strength of the radiocarpal ligaments also ensures that when the radius rotates, the hand goes with it. Before we move on to look at the muscles, let's review what we've seen of the bones and joints. On the humerus, here's the medial epicondyle and epicondylar ridge, and the lateral epicondyle and epicondylar ridge. Here's the capitulum and the trochlea. On the proximal ulna, here's the trochlear notch, the olecranon, the coronoid process, the ulnar tuberosity, and the radial notch. On the proximal radius, here's the head, the neck, and the radial tuberosity. Here's the radial collateral ligament, the annular ligament, the ulnar collateral ligament, and the joint capsule. On the distal ulna, here's the head and the ulnar styloid. On the distal radius, here's the surface for the ulna, the surface for the wrist joint, and the radial styloid. Here's the scaphoid, the lunate, the triquetral and pisiform, the trapezium, the trapezoid, the capitate, and the hamate. And here are the metacarpals. At the wrist, here's the triangular fibrocartilage, the radial collateral ligament, the ulnar collateral ligament, the palmar radiocarpal, and dorsal radiocarpal ligaments. Now let's look at the muscles. There are three sets of muscles to look at: the ones that flex and extend the elbow, the ones that pronate and supinate the forearm, and the ones that flex and extend the wrist. We'll look at each set of muscles separately. Later on in this section, we'll see them all together. First, the muscles that flex and extend the elbow. There are three flexors and one extensor. The three flexors are brachialis, biceps, and brachioradialis. Here's the brachialis muscle. It arises from this broad area on the anterior humerus. It's inserted here on the ulnar tuberosity. The action of brachialis is to flex the elbow, which it does equally well whether the forearm is pronated or supinated. The biceps muscle, its full name is biceps brachii, lies in front of the brachialis. It's a more complicated muscle. For a start, it has two heads, a long and a short. To get a good look at them, let's take away the anterior third of the deltoid muscle and also pectoralis major. Here's the long head of biceps. Here's the short head. The tendon of origin of the short head merges with that of another muscle, coracobrachialis. Their common tendon of origin arises from the coracoid process. The tendon of the long head of biceps makes a strange journey. It runs up the bicipital groove and passes inside the shoulder joint to reach its origin from the supraglenoid tubercle of the scapula. The two heads unite to form a single belly, which narrows to form this unusual two-part tendon. The main part dives down between the radius and the ulna and inserts on the radial tuberosity. On its lateral edge, the tendon fans out, here it is in the intact forearm, into a thin sheet of fascia, the bicipital aponeurosis, which becomes continuous with the deep fascia that surrounds the forearm. The aponeurosis gives the biceps an indirect attachment to the ulna. The biceps flexes the elbow. It does this more efficiently when the forearm is pronated, because then it's fully stretched when it starts its action. The biceps can also be a powerful supinator of the forearm, as we'll see later. The last of the three elbow flexors is brachioradialis. It arises halfway up the humerus, just below the deltoid tuberosity. It's inserted all the way down here on the distal radius. Brachioradialis is an efficient flexor of the elbow, whether the forearm is pronated or supinated. The action of the flexors is opposed by just one extensor muscle, the triceps. The triceps muscle has three heads: a long head, a lateral head, and a medial or deep head. The long head arises, as we saw in the last section, from the infraglenoid tubercle of the scapula. The lateral head arises high up on the lateral side of the posterior humerus. The medial head arises from a broad area lower down and more medially. As we'll see, the radial nerve runs next to the bone between the lateral and medial heads. The three heads of triceps converge to form this massive tendon, which inserts here on the olecranon. Contraction of the triceps